Alright, so we're going to talk about a special right triangle, and we call this special right triangle the 45-45-90 right triangle. And your learning target is I can justify and apply properties of 45-45-90 triangles. Alright, so first let's talk about what is a 45-45-90 special right triangle. And so we're going to just read this off here. It says a 45-45-90 triangle has two congruent legs and has a right angle. We could also call this, and this is what I want you to write down, we could also call this the isosceles right triangle. Isosceles right triangle. Remember, an isosceles right triangle means that it has a right angle, and it also means, isosceles means that it has two congruent legs, okay? So your key concept here, in order to solve problems involving the special right triangle 45-45-90, we need to first label all sides, second, solve for x, and lastly, substitute the new value in for x. Alright, so example 1, we need to find the value of x and give your answer in simplest radical form. We see we have an isosceles triangle, 45-90-45 triangle, because the only distance that this could be is 45, which means that this length right here has to be 8. Okay, so we've labeled all sides, and now we need to solve for x. We have to solve for x. Okay, now to do this, we're going to use our same little method here. We've got a squared plus b squared is equal to c squared. That's the Pythagorean theorem. And if we plug our numbers in here, we know a squared is 8, b is 8 as well, which means c, our x, is going to be x squared. Add these two up, we get 64 plus 64, which just equals 128. Now to get rid of that x squared, we take the square root of both, and we're going to have to branch this one out, right? We can use two numbers here. We can use the square root of 64 and the square root of 2 in order to do that, simplify that radical, and we see that we end up getting 8 times the square root of 2 is equal to x. Okay, now here's something very special I want you guys to see. I want you to see that we have the 8 right here. That 8 is the same length as the side. Okay, the radical here is just the square root of 2. What you'll end up finding is that this, in an isosceles right triangle, in a 45-45-90 triangle, the x value, or the hypotenuse, is always going to be the leg, the length of the leg, times the square root of 2. Okay, so I want you to go back up to the key concept here, and I want you to draw this triangle. Okay, this triangle is going to be a right angle triangle with 45 degrees on both sides, making it an isosceles right triangle. Here is a very important rule, and I want you guys to write this out so that this will make a little bit more sense to you guys. This value right here, we're going to call this L, the side length L, which means if this is a side length L, then this also needs to be a side length of L. Okay? And if that is the case, then this hypotenuse for an isosceles right triangle will always be L times the square root of 2. This is really going to help us understand how to solve these types of problems, so that if you are given a problem, by just looking at it, you might be able to actually go and solve it, right? For example, on this first example, if we knew right off the bat that example 1 that this was 8, then we knew the hypotenuse would be 8 times the square root of 2. There wouldn't be much work that you'd have to show for it, because it's just the simple, or the special right triangle rule, that the hypotenuse is always the length of the leg times the square root of 2. Alright, example 2 here says find the value of x and give your answer in simplest radical form. So we could do the same type of thing using Pythagorean theorem to do x squared plus x squared equals 5 squared, and then try to solve for what x is going to be, and we would get the right answer for that. But remember, what I just said with that special right triangle is that the hypotenuse, 5, is equal to the side lengths x times the square root of 2. This will prove to be a lot easier in trying to solve for the value of x. Now we can just divide by the square root of 2 on both sides. And we're going to get 5 divided by the square root of 2 is equal to x. Okay. Now remember, a radical is never simplified until you get the radical out of the denominator. So we're going to have to multiply by the square root of 2 on both sides. Or sorry, not on both sides, on the numerator and denominator. That'll cancel out that radical. And we'll be left with 5 times the square root of 2 divided by 2 is equal to our x. And that is the answer for the value of x. Alright, example 3 says Jana is cutting a square of material for a tablecloth. The table's diagonal is 36 inches, and she wants the diagonal of the tablecloth to be an extra 10 inches, so it will hang over the edges of the table. What size square should Jana cut to make the tablecloth? Okay, so first let's go ahead and build a table, and remember our table is a square. So we're going to attempt to draw a good square. Should be something like that. And the diagonal of the table's, this is 36 inches, right? But she wants the tablecloth to go over an extra 5 inches on both sides, right? On both sides, she wants it to be 10 inches longer in total length, so an extra 5 inches on both sides. Okay, now we're trying to figure out what should our length of, so this dotted line right here is the tablecloth. What is the length we should have for our square in the legs of our square, right? Alright, so we can use this exact same type of thing that we've been doing. We know that this is our right angle, which means our hypotenuse is 36 inches plus 5 inches plus 5 inches, which is a total of 46 inches. 46 inches. And based on that special right triangle thing, the little triangle we built from the front page, we know that this length right here is equal to the length of the sides of the legs, right? X times the square root of 2. Okay, so now again it's just trying to solve for the value of x. We have to first divide by the square root of 2. And we end up getting 46 divided by the square root of 2 is equal to x. Okay, now we found out what x is, but we've got to simplify this this fraction here because we do not want a radical in the denominator. So we're going to go ahead and multiply by a fraction of the square root of 2 over the square root of 2. Because if we do that, when we multiply the denominators, those will get rid of the radical. Okay, so 46 times the square root of 2 divided by square root of 2 times the square root of 2 is just 2 is equal to x. Then the last step here, all we have to do is just simplify this fraction because 2 goes into itself and 46. Cancels out once. This goes in 23 times. So our answer is 23 times the square root of 2 is equal to x. And that is the size of the square that we need to have. Now it asks us to give it into the nearest inch, and so what I would do in this case is I would get our calculator, say hi friend, and I would take this 23 times the square root of 2 to see how many inches that would be. It would be approximately, if we were to round this up, 33 inches then. 33 inches. So we'll write on this side equals 33 inches. And that's our problem.